everyone, today we will present our project Crude Extract from Thunbergia Laurifolia leaf by synthesis as the reducing agents of silver nanoparticle to inhibit pathogenic bacteria that cause disease contaminating on surface area exposure. This is our team.
First, we start with introductions. Contaminations in the environment affect the health of people living in that area, particularly the disease, and that can spread to the environment. So, prevention of infection is cleaning. Silver nano is the one of many alternatives. Furthermore, there are three ways to synthesize silver nanoparticle: is chemical approach, physical approach, and biological approach. The researchers have chosen a biological approach because it's very friendly method to the environment, low cost, and easy to synthesize. And using Thunbergia Laurifolia leaves to a reducing agent because in Thunbergia Laurifolia leaves have ability to antitoxins, antioxidants, and inhibit bacteria. Moreover, in Thunbergia Laurifolia leaves, we also found the flavonoids that help with reducing silver and help not to form a unified nanoparticle into a massive particle.
Next, methodology. Step 1. Extraction of Crude Extract from Thunbergia Laurifolia leaf by solid liquid extraction method. The leaf are chopped and heated in hot air oven, then dissolved 2.5 grams of leaf with 100 ml of ethanol at 50 degrees Celsius. After that, Crude Extract was filtered. Step 2. Analysis of flavonoid by the Sena reaction. 3 ml of Crude Extract and magnesium wire in the test tube. 5 drops of hydrochloric acid were mixed after that. Step 3. Synthesis of silver nanoparticle from Crude Extract by green chemical synthesis method. 145 ml of distilled water were heated 90 degrees Celsius. Then 50 millimolar of silver nitrate, 75 millimolar of titanium citrate, and 1.75 millimolar of sodium borohydride were added into the solution and synthesis. Silver nitrate by using Crude Extract as a reducing agent was using the same method as disodium citrate. Then measure its absorbance. Silver nitrate was measured by using a UV spectrophotometer. Step 4. Test for inhibition of pathogenic bacteria by agar-dip diffusion method. The test substance was dipped, distilled water, the Crude Extract, amoxicillin, silver nitrate from sodium borohydride and silver nitrate from the Crude Extract and dropped them in 10 ml. Finally, it was incubated at 37 degrees Celsius for 24 hours, and the diameter of the inhibition zone was measured by vernier caliper.
For the result and discussions, we have 3 steps, with the result from Step 2, Step 3, and Step 4. First, the result of Step 2, analysis of flavonoid by the cyanidin reactions for the color of extract is changed from green to yellow when magnesium was react with hydrochloric acid in the extract, so the flavonoid is a chemical component in the extract. Next, Step 3, synthesis of silver nanoparticle from the Crude Extract by green synthesis method is brought for that the color of the solution changes from clear to yellow when the Crude Extract from Thunbergia Laurifolia leaf bursts react with silver nitrate solutions. Due to the reducing reactions of silver ion, silver nanoparticles are formed, and they were characterized by UV spectrophotometry in the wavelength range of 300 to 750 nanometer. The UV spectroscopic analysis showed the absorbance peak at 414.6 nanometer, which is mirror to the silver nanoparticle that use sodium borohydride as a reducing agent. That's at the standard in the synthesis of silver nanoparticle, which had the absorbance peak at 414.2 nanometer. Moreover, it is also consistent with the research of Pathogenic showing the absorbance peak at 420 nanometer. And finally, the research of Step 4. Test for inhibitions of pathogenic bacteria by agar-dip diffusion method by silver nanoparticle using Crude Extract from Thunbergia Laurifolia leaf as reducing agent show the size of the clear zone to inhibit Escherichia coli and Staphylococcus aureus were 2.70 plus or minus 0.30 cm and 2.54 plus or minus 0.17 cm respectively. Therefore, the results show that silver nanoparticle of the Crude Extract from Thunbergia Laurifolia leaf can inhibit bacteria on the exposed surface.
In the conclusions, as a result, the glow of bacteria on the surface was inhibited by silver nanoparticle from Crude Extract. So, this research is another alternative for further study to take Crude Extract from Thunbergia Laurifolia leaf and use it as a reducing agent to make silver nanoparticle in order to be applied in different ways. For example, it develops product quality for cleaning the texture and increase the value of Thai earth.
Thank you.